Hello guys, welcome to Learning with Lai. Today's topic would be about scalars and vectors. I talked about physical quantities in my introductory video, whereby we classified it into two, having both derived quantities and fundamental quantities. These physical quantities can be classified into scalar quantities and vector quantities. And from here now, scalar quantities are quantities that have only magnitude but no direction. So they have only magnitude, no direction. Where magnitude can also be referred to as size, and with this phrase, it can also be referred to as to what extent. And these quantities don't involve direction, and we can look at some real life examples of scalar quantities. Let's take, for instance, we have a 5 liter cup filled filled with water. 5 liters cup filled with water. We also have population of students in a classroom. Students in a classroom. How hot or cold an object is. How hot or cold an object is. And these are real life examples of scalar quantities. And if you look at this now, 5 liters cup filled with water, all what we're concerned is the size or to what extent the cup is filled. Also, the population of students in a classroom. You can see that we're only concerned about the size, the numbers of students. We don't have any relationship with direction, because all what we're going to consider about the population of students in a classroom is either we need to know the numbers of boys or numbers of girls, and how hot and or cold an object is how we can perceive the object with our sense organs, either maybe we feel it with our skin or with our tongue. So now if we try to look at scalar quantities in terms of physics, we have some quantities such as distance, we have volume, density, time, mass, current, and so on. We have a lot of them like that. So now we can notice that scalars only have size, and if you look at each of all these quantities, there's no correlation about direction there now. But why vector quantities are quantities that have both magnitude and direction. So the only difference between vector and scalar is direction. So, and direction, considering some of the scalar quantities, they give birth to or produce vector quantities when considered under certain condition. So under some critical condition or some certain condition, some of all these scalars will produce a vector quantity. E.g., let us look at distance now. I'll do that on a newer page. If we have a person here at point A, this is a person at this point, is moving towards point B, he gets to point B, Now the person doesn't now move in a straight path. The person now decides to go like this in this kind of wavy direction and gets to point B. All what the person has done from point A to point B is what we call distance, because distance is also related to length. So the length from A to B, that's what we call distance. This wavy line is called distance because we're not moving in a specific direction. This is not a specific direction. We're moving in a kind of random movement. We're going left, right, swinging from left to right till we got to point B. But now let us now consider moving in a straight path now, in a straight line. So moving in a straight line, we've already restricted ourselves to moving in a straight line. This is now the condition. And this now produces, instead of still having distance, which is still also going to have the same SI unit as distance, we're now going to have displacement. So we can now see that scalars, when set under certain condition, can produce vector quantities. Also, when we look at the mass is the amount of matter in a body, e.g. a stone, a parcel, and so on, which is also measured in kilograms. That's the SI unit. But when we consider a stone now, which is a mass, we consider a stone. If this is a stone, around this part, we have something like this. It's being hung freely on this rope or resting on a support or at rest. Force of gravity is always acting on this mass. Now we're not putting a certain condition, but if we're not putting that condition, we only have mass. But when we now apply force of gravity on this mass now, on this stone, it now produces a vector quantity which we call weight, and the SI unit is in newtons. You can now say that the SI unit for weight now is different from the SI unit of mass, and we can note that mass is measured in kg, and the new term, because of force of gravity is acting on it, we're not applying it, we're not putting that condition. If force of gravity is acting on this, because force of gravity is always acting on it, when we now consider that condition, we're not going to have a new quantity, produce a new vector quantity, and that will be weight, and this is measured in newtons. So we can now see that force of gravity always act downward. It always pull object towards the center of the earth, and force of gravity always have a direction which is always downward, and all kinds of force always have a direction. So we can see that the key thing about vector quantities is the direction. So now we can write our examples on vector quantities, and we have examples on vector quantities. We've listed the first two examples here. We have displacement, we have weight, we also have more examples. We have acceleration, we have momentum, we have pressure, impulse, and so on, like that. So now, but most of these vector quantities, when we check up their makeup, like their relationship with other quantities, we see quantities that strongly depend on direction, which makes them become a vector quantity. Let us look at pressure now. If we have pressure, let me write it here. We have pressure. Pressure, the formula of pressure is force applied over the area. And we can see that we've noticed it that force always have direction. That's why we can see it is affecting this quantity. That's why it is a vector quantity. If we also check as a velocity, velocity is displacement over time. And you can see that displacement is always in a specific direction. Also, we have momentum. When we check it, momentum is equals to mass times velocity. And we can see also that velocity from here, we already declared it that it is a vector quantity, and that's why it is also affecting mass to produce a vector quantity. So that's how more of the other vector quantities, when we check up their makeup, we will see a vector quantity that is being affected by direction, which now produces newer term, which is also a vector quantity. We can also add our cardinal point here to indicate the direction. So we can see that we have our direction here now to indicate that we're talking about a vector quantity. So in this kind of direction now, because this is north, east, south, so this will be around the southeast direction. And in this place here now, instead of us, we could have here measured in the distance from A to B could be, let us say, 10 meters. And this one now, if this will now be 10 meters in the southeast direction, whereas if you measure the length of this wavy line, it could actually be 25 meters. So I can see that there's a difference in the distance, but in the length between the 2 points. So and that's why we have vector quantities being affected by direction. You can see it here, moving from point A to B. This is a straight path in the southeast direction. So it goes on like that, and that's it about vectors and scalars. So if you have any suggestion, comment, please kindly drop them below, and please don't forget to click the like button and subscribe.